Okay, well, let's first talk about what's on there, how big, how many questions, all of that important stuff, so that we get that done before we run out of time. Okay, you are looking at 21 multiple choice. You've actually had unit exams that had more multiple choice on them than that, but 21 is the number of multiple choice questions. Okay? And there are 12 written. The multiple choice does go in unit order. Okay, so you won't have like a random smattering of, oh, there's a Newton's second law question, and then a satellite question, and then a waves question. It's going to be all kinematics, and then all dynamics, and then all circles, and then all waves and simple harmonic motion in the multiple choice. It does not do that in the written simply because I have some questions that overlap. Okay, so it's a question, but in it, there's stuff that kind of involves more than one unit. Okay? All right, so if we're talking about the written response, okay? If I could pick one single question type from Unit 1 that would test more things than anything else, what would it be? That would test more concepts from Unit 1 than anything else, what would it be? Projectile motion. Okay? It tests everything but but graphs. Okay? That's the only thing it doesn't test. It tests V equals d over t. It tests vector components. It tests acceleration. Okay? All of that stuff. So it's all in one question. That's awesome. That means less questions for you. Okay? So projectile motion question, definitely. Okay? Very much like the ones we did in class. Okay? And I will tell you, it's projected at an angle because otherwise it wouldn't have the vector components part in it. Okay? Since the only thing a projectile motion question can't test from Unit 1 is graphs, guess what else is in the written response? A graph. Okay? So being able to interpret, okay, either velocity time or position time. I'm not going to say which, but okay. There's a graphing question on there. Okay. Okay, there's a gravitational field strength question. All right, going to Unit 2. What's my favorite kind of Newton's second law question? Inclined planes. I always go with my favorite. Okay, it also involves some vectors, so in that way it tests a number of different things. This one, I will tell you, involves systems as well. Okay? So remember that in a system, the net force acts on how much of the mass? All of it. Okay, so if there's more than one mass, it's a system, and the net force acts on all of the mass. Okay, then you have a law of conservation of mechanical energy question. It did, after all, appear in 2 units in this course, so it's definitely got to be in the written response of your final exam. Okay, and then you have a vertical circle question. Then you have a satellite motion question. Then Doppler question. That I would say is slightly easier than the one in your unit exam. Okay, and then you have an error column question. And the reason for that is that it tests lots of things. Interference, standing waves, universal wave equation. Okay, and then you have a curve question. I'm not gonna say whether it's banked or unbanked, okay, but you have a curve question. So a very basic uniform circular motion question. Okay, and then you have a question that involves Newton's second law and vector component addition. Okay, so how do we add vectors? Put them tail to head, find the x's, find the y's, add the x's, add the y's, okay, find your resultant, okay, just this one also involves Newton's second law. You had one on your test, I think it was about two kids making a snowman, okay, and they were both pushing the ball in a different direction. Okay. Right, and then your last question is also a Newton's second law / friction, force of friction question, because friction came up in both the circular motion unit and unit 2. Okay, this is a unit 2 based friction question, and it's pretty easy, as long as you don't overthink it. Okay, the marks are distributed pretty evenly unit by unit. Okay, I think when I did the math on it, it was like 24, 26, 23, 27, I think, like something like that. So they're all pretty close to the same percentage of the final. Okay, if one unit got more than any other, it was probably unit 2. Okay.
How many marks is the whole thing out of?
The whole test is out of 85. Okay, so there's 64 marks in the written. Okay, the multiple choice involves very little calculating. Okay, it's mostly like recall of concepts. Okay, any calculations in the multiple choice would be 1 mark type calculations where you're basically plugging numbers into a formula. Okay, they're not going to require you to do any major manipulation if there are any. Okay, trying to remember, that might be 1. Okay, but yeah, everything else is just concept recall, okay, and application. Okay. Sure. Yeah. All right, I'll take your questions rather than do like a full review in case you guys have particular things, because I said a good idea for you to go over your stuff and see if you have questions.
You have some projectile motion questions?
Yes, projectile motion question. I don't have a projectile motion question. Oh, yes, I do. There. But it's terrible, so I'll just make it fun. Okay, so we have this object projected at a 30-degree angle at 60 meters per second, and I want to know How far? How high? So maximum height and maximum horizontal distance traveled. Okay, so in this projectile motion problem, we know that the projectile is going to do this. It's going to follow that arc that will re-encounter the ground at the same height it was fired from, okay? And that motion will have a vertical and horizontal component. Okay, now the vertical component, or initial vertical component anyway, is calculated by finding this side of the projected triangle. Okay, it's the opposite side, so I'm going to go that initial vertical velocity equals the sine of 30 times 60, which ends up being 30 meters per second up. Okay, what else do we know vertically? We know the acceleration, negative 9.81 meters per second squared. Okay, and what else do we know since it hits the ground at the same height it left? Okay, we know the displacement is 0, vertical displacement is 0, yeah. What else do we know? What's VF?
0 opposite.
It's opposite, yeah. What goes up must come down, right? From a vertical perspective, it's going the same distance at the same rate of acceleration, so it's got to come back at the same speed it left. That's the trick to these ones. Okay. Horizontally speaking, okay, I need a horizontal velocity, which is constant because there's nothing to speed it up or slow it down. Okay, so that's going to be the adjacent side, so I'll go cos of 30 times 60. .96 meters per second, and of course I'll keep all those decimals in my calculator. All right, first thing they wanted was how far it would travel horizontally. What am I missing? Time. Does time apply to both?
Yeah.
Okay. Can I calculate with this? I can. Yeah, I've got VI, VF, and A. I don't even need D. Okay, I can calculate the time by going VF minus VI over A using the acceleration formulas. All right, so that'll be negative 30 minus 30 divided by negative 9.81. Okay, so we're going to have basically negative 60 divided by negative 9.81. All right, so that thing is going to be in the air for 6.11, well, it's actually 6.12 seconds. Which means I can bring that over here, and now I can go D equals V times T. So 51.96 times 6.12. Whoops, sorry, I don't want to do it that way. Do that. All right, so it's going to travel, we have two significant digits, 3.2 times 10 to the 2 meters. Okay, is that part ringing a bell? Okay, the other thing I'm supposed to calculate is the maximum height. Okay, that occurs right here. What changes? Time is half, and VF is 0. So there's two ways to calculate this. Okay? I like using the VF is 0 way because it doesn't involve having to remember I'm supposed to divide the time by 2, which is what people forget to do when they use the time method. Okay, so I like using this formula here. VF squared equals VI squared plus 2AD, okay, and I simply solve for D because that will be my vertical displacement at this point, which is my maximum height. So VF squared minus VI squared divided by 2A will equal D, so 0 squared minus 30 squared divided by 2 times negative 9.81. All right, so we're gonna have 30 squared divided by 19.62. All right, it's gonna reach a maximum height of 46 meters. Okay, the other way to do that is you can use this formula. D equals VI times T plus 1/2 AT squared, remembering to divide your time by 2 and just plugging in the numbers. Okay, that will also work. All right, I would not say that your question on your final would be much different. What do you need to bring to your final? Sorry, say. What do you need to bring to your final? Calculator with fresh batteries or freshly charged. Okay, you need to bring something to write with, and that's at the bare minimum all you need. Okay, you obviously can't bring your phones. Okay, leave them somewhere else. I mean, you can bring food or drink. Just make sure it's exam appropriate. Okay, not a full 5-course meal. Okay, stuff like that. And I think I told you guys this, but I won't be at your test. Okay, so you guys are writing in here, okay, in my room. So come here 8:45 on the 26th. Okay, the tests will be laid out in alphabetical order, but the desks will be arranged this way. Okay, so A will start over by the file cabinet. Okay, and then the bottom of the alphabet will end over here. All right, so you can kind of have an idea of where to look for your test based on that. Okay, Mr. Dickey or whoever is supervising this one, it might be Mrs. McElroy, so I will put out instructions on how to clear your calculator. Okay, it's just a little sheet. Looks like that. Okay, has pictures and everything. Okay. If you follow the instructions on there, your calculator will give the really happy mem cleared, not RAM cleared, mem cleared sign on the screen. Leave that out so that whoever is supervising can come around and check and verify that your calculator is indeed cleared. Okay? And then, after you do that, what mode do you need to put it back in? Yeah, because it'll go back to radians if you don't. Okay? And that would be really bad, because there's a fair amount of vector stuff on here. And it really gets screwed up if you don't put it back in degree. Yes. Go sine of 90. If it comes out to 1, back in the right mode. If it comes out to anything else, it's still radians. Okay. Yeah, so that'll be basically all you'll need to know. Okay. I will come back and get those tests later that night, and I have to have them marked because my marks and comments are due the next morning. So I will have them marked and entered complete with report card comments by noon the next day. Okay, for sure they'll be in by then, if not before that. I intend to drink a lot of coffee and mark into the wee hours that day. Okay, so yeah, just know I'll get it turned around quick. All right, any other questions from you guys? We got 9:40. We still got some time if you got something you want to ask about.
Can you do a vector addition?
Vector addition question, sure. It's not going to have a creative context. Okay. Yeah, try that. Yeah, give you a minute to get the diagram drawn, then I'll draw it. So if we're looking at a vector diagram for this one here, okay, we'll have our first vector going north of east, so my reference line is east. Okay, and I'm going to go 20 degrees north of that for 10 meters. Those look wrong. Okay, and then our other vector, okay, is gonna go, it's from west of north, 60 degrees west of north. Okay, there's my north reference line, 60 degrees for 25 meters. Probably should have positioned that differently, but that's the way it worked out. Okay, this will be y, this will be x, that'll be 60 degrees, and that'll be 25 meters. Okay, which means my resultant is going to go like this. You could also draw it this way. I just don't ever do that if I can avoid it, because it goes through my diagram and starts to look messy. But if you drew it that way, totally up to you. Okay, or if you drew separate triangles, also totally up to you. All right, next thing we got to do is calculate all of our x's and all of our y's. Okay, so this x here is the adjacent side, so cos of 20 times 10. Okay, 9.39. Okay, and that's east. Okay, sine of 20 times 10, 3.42. North. Okay, green x is cos of 6 or sine of 60, sorry. 60 times 25. Okay, 21.65 meters west. Cos of 60 times 25. 12.5 meters north. Okay, and then we get our purple x and purple y by adding our x's and y's together. Okay, so we're going to have our 21.65 minus our 9.4 because they're opposite. Okay, so we're getting 12.25 for this x. Okay, the two norths are going to get added together, right? So that'll be our 3.42 plus our 12.5, okay, 15.92 meters. Okay, and then we do Pythagorean theorem. So square root of that number squared plus that number squared. Okay, there's our resultant, 20.08 meters. Our vector, okay, will be the inverse sine, or sorry, inverse tan, sorry, of opposite, so the 15. Okay, divided by the adjacent, 12.25. So 52.4 degrees. And that'll be north of west, the way I drew it. So our final answer to two significant digits, 20 meters at 52 degrees north of west. Oh, that was fast. Okay, all right. If you have questions during exam time, you can email me. I'll do my best to get back to you with answers if I can, because there's really not an opportunity to have everybody come in for help. Okay.